There is roughly a month to go before the Brexit day. However, every protocol has failed due to the border issue between the Republic of Ireland and Northern Ireland. The 300 border is a central issue in the negotiations, the longest 300 miles. There is only land border between the UK and the EU, across which people, goods, services, and capital can move free. But after Brexit, this will be hindered by the hard border, which are against the peace agreement. So EU proposed that Northern Ireland stay within the customs union, but here comes a problem of sovereignty. Then the EU proposed the whole UK stay within the customs union, which hurts the trade policy independence. Therefore, we have three possible positions to put our hard border if there must be one: case A, case B, and case C. Both of the UK and the EU have the red lines. The question of interest is how to respect these red lines and solve it soon. The answer is the bargaining process itself. Here we have our assumptions. Two players, rational and maximize expected utility, complete information. The bargaining stops only when one side accepts the offer, and the players make offers sequentially and the delays are costly. Every time we will discount with the common factor A. And a specific assumption. For simplicity, we assume the UK is strongly determined to withdraw, and he prefers A to B and to C. The EU is preferred to increase his single market, so he prefers C to B and A. So the bargaining on their share of total payoff represents the trade-off zone arrangements. Where is the border? How to solve the problem? We talk about it in two scenarios. Scenario one is the bargaining with a finite horizon. First, the player 1 offers S1, and the player 2 can accept or reject and offer S2. And thirdly, player 1 can accept S2 or offer S3. S3 must be accepted. So we will go back forward induction. And stage 2, player 2 offers S2 to maximize his payoff, which must be acceptable to player 1. So we have this function and we solve for the S2. And at the second stage, the payoff is calculated. Player 1 is indifferent while player 2 is happier. So similarly, at the first stage, player 1 has these relationships, so the payoff should be calculated as below. This bargaining actually ends in the first offer. Actually, because S3 will be implemented anyway, so player 1 will choose S3 equals 1. Therefore, there is a unique equilibrium as calculated. The relative size depends on the size of A minus A squared. And when A equals 0 or A equals 1, player 1, the UK, don't have to share or compromise with the EU. And A equals 0 means the EU has no bargaining power. Negotiations will cost her everything, but this is not realistic. And A equals 1 means the UK does not care the delays, which is not realistic. But A can be very close to 1 if UK is happy with a no-deal Brexit. The scenario 2 is, here we are bargaining with the infinite horizon. Just think about it. Suppose two strands, both of infinite length, cut down the first few meters from one strand. They are still of the same length. So similarly, if the bargaining is unlimited, there is no matter begin from the first stage or from the third stage. The result should be the same. If the bargaining is unlimited, then no matter begin from the first stage or from the third, the result should be the same, which means S1 equals S3. From scenario 1, we can solve the value of S3 and then calculate the equilibrium. So at the first stage, we have the unique subgame perfect equilibrium. This is the solution that we are looking for. However, the reality is that information are not perfect. The good thing is that we can find an equilibrium. This is the result of compromise. And thirdly, EU's bargaining power is UK's cost of delay. To save time, player 1 would actively negotiate with player 2. But there's an empirical puzzle. Then UK adopted a hard bargaining approach from a position of weakness. Smart bargaining strategies make sense only when having a significant advantage in bargaining power.